Hello everyone, welcome all to Physics with Astronautics. So in this video we will discuss about uh, the 2023 cpet physics solution, and this will be our last session, and let's begin. And here's our first question of the session, and that is, if Z is the partition function for an ideal gas, then total internal energy U is. And here the options are n kb ln Z, n kbt square del by del T ln Z, n kbt ln Z, and n kbt square ln Z. So let's see what will be its solution. And here's our solution. That is, we know that U, that is the internal energy, is equal to minus del by del beta ln Z. And here it can be differentiated as minus 1 by Z del Z by del beta. Again, we know that the beta value is equal to 1 by kT. So from here we can write it as kT will be equal to 1 by beta. And when we differentiate this part, that each k delta t by del beta will be equal to minus 1 by beta square. That is, differentiate this part with respect to beta. And from here we can get del t by del beta will be equal to minus 1 by k beta square. So because we know that the beta value is equal to 1 by kt, so by putting the value of beta here, we can find the final result as minus kt square. That is, del t by del beta is equal to minus kt square. And here we can see it as minus 1 by z del z by del beta can be written as minus 1 by z del z by del t into del t by del beta. So by putting the value of del t by del beta here, we can find the result as minus 1 by z del z by del t by del beta is equal to minus 1 by z del z by del t, and this is minus kt square. So this minus and this minus will become plus, and here we can write it as kt square 1 by z del z by del t, that is kt square 1 by z del z by del t, and then kt square del by del t ln z, that is 1 by z del z by del t will be equal to del by del t ln z. And again it has been asking that the total energy will be, so by multiplying the value of n, here we can get the final result as n kt square del by del t ln z. So the option B is the right answer. And then the second question says, product of wavelength corresponding to maximum energy lambda n and absolute temperature T is constant. That is, lambda mt is equal to constant H. And we have to find out whose law is this. So the options are Stephen-Boltzmann law, Rayleigh's law, Wien's distribution law, and Wien's displacement law. And we all know that this is Wien's displacement law, that is lambda mt is equal to constant, that is maximum lambda into absolute temperature is constant. Then ripple factor for a full wave rectifier is. The options are 0.482, 1.21, 1.1 and 2.1. So we know the formula for ripple factor, that is gamma is equal to root over of V RMS square minus VDC square whole divided by VDC, or here we can write it as I RMS square minus IDC square by IDC. So by calculating it, we can find the result in full wave rectifier and pitch rectifier. This will be 0.48, and in half wave rectifier, the gamma value will be 1.21. So because here it has been asking about the full wave rectifier, so our result will be the option A, that is 0.482. And then if the emitter collector current can factor alpha is 0.95, then the base collector current can factor beta is what? And the options are 25, 10, 19 and 30. So we know the relation between beta and alpha as beta is equal to alpha by 1 minus alpha. So here it has been given that alpha is equal to 0.95. So by putting the value here, we can find it as 0.95 by 0.05 will be equal to 95 by 5, and the result will be 19. So here the option C, that is 19, is the correct answer. And then for Hartley oscillator, L1 is equal to 8 mH, L2 equal to 12 mH, and M equal to 8 mH. And here C1 is given as 10 microfarad. Then frequency F each. And here the options you can see. So let's jump to the solution directly, and if we know the frequency formula for it is equal to 1 by 2 pi root over of LTC. And here LT value will be equal to L1 plus L2 plus 2M. So by putting the value here as given in the question, we'll find the final result as 1 by 2 pi 10 to the power 4 by 6 Hertz. So this is matched with the option B. So here option B is the correct answer. The ideal op-amp hedge, and the options are an infinite voltage gain, finite input impedance, finite bandwidth, and non-zero output impedance. So we know the characteristics that each in an ideal op-amp, it has open loop gain is infinity, input resistance is infinity, output resistance is 0, and bandwidth of operation is infinity, and offset voltage is 0. So here the correct answer will be the non-zero output impedance. Then addition of 11001100 and 10001010 each. So this is basically in the binary system. So when we add it, the final result will be 1010101110. So option C is the correct answer. The Lysage's figure is produced by application of sinusoidal voltage to vertical and horizontal deflecting places of CRO. The pattern gives 4 tangencies with vertical and 3 tangencies with the horizontal. The frequency of the vertical signal for 1 kHz horizontal signal each. And we know the formula for it, that is the tangencies with the horizontal by with the vertical is equal to frequency of the horizontal signal by frequency of the vertical signal. So by putting the value here, we can find the frequency of vertical signal h 1333.3 Hz. So option C is the correct answer here. Then Boolean identity ABC plus AB dex C plus AB C dex each. And we have to solve this equation, that each ABC plus AB dex C plus AB C dex will be equal to, when we'll take ACH common, this will be AC B plus B dex plus this is AB C dex, and we know that B plus B dex is equal to 1. So here this will be AC plus AB C dex, that is the option A. Then in decimal system, the binary number 11011.1101 each. And we have to find out the decimal system of this binary number. So what we have to do is, first we have to count. It is 1, 2, 3, 4, 5. And so here we have to multiply 1 into 2 to the power 4 plus 1 into 2 to the power 3 plus this 0 plus this 1 into 2 to the power 1 and this 1 into 2 to the power 0. And after decimal, what we have to do is plus 1 into 2 to the power minus 1, this 1 into 2 to the power minus 2, this will be 0, and this will be plus 1 into 2 to the power minus 4. And by adding all these values, we'll find the final result as 27.8125. that is option D. I hope you all enjoy the session. So for more videos, please to like, share and subscribe. Thank you.